Welcome back. So today I would like to explain the high frequency model of BJT and short circuit current gain using high frequency model. So in case of high frequencies, the stray capacitances and inter-electrode capacitances may affect the gain of the amplifier. So that with reference to higher frequencies, the various components along with the R pi and GM V pi or VBE we need to consider. Let us see the hybrid pi, not hybrid pi model, okay, hybrid pi equivalent circuit at higher frequencies. So this is the diagram. This is the equivalent circuit for the transistor between emitter, base and collector terminals at higher frequencies. Okay, it includes the resistors RB between external base to internal base terminal, and REX, this is the resistance between external emitter terminal to internal emitter region, and RC is the resistance between external collector terminal to internal collector region. R mu is the resistance between base to collector region, whereas these are the various resistances between external terminals to internal regions. Similarly, different capacitances like C pi. C pi is the diffusion capacitance between base emitter junction. Between base emitter junction, the inter-electrode capacitance is C pi. Similarly, between collector and base, the transition capacitance or reverse capacitance C mu. Okay, and another capacitance is CS. This is the capacitance between collector and substrate. So in addition to R pi, GM, VB or V pi current source and small r naught resistor, various resistors and capacitors we need to consider in the hybrid pi model at higher frequencies. Okay, at higher frequencies. So using this high frequency model, now let us see the short circuit current gain of SEE amplifier. Okay, that is let us see the simplified equivalent circuit. The simplified hybrid pi equivalent circuit neglects all the external terminal to internal region resistances and CS capacitances. Only the diffusion capacitance, that means between base to emitter junction C pi, and the transition capacitance between collector to base, that is C mu, those two are only considered. Okay, now let us see the derivation for short circuit current gain. Short circuit means output in short. With reference to this, the current gain we are going to derive now. So when the output is short circuited, R0 also becomes short. Okay, now with reference to this diagram, first of all write the input KCL equation. The KCL equation at the input node B or base. The KCL equation at node B is IB. Okay, KCL equation is incoming currents equal to outgoing currents, right? So IB equal to V pi by R pi plus V pi divided by C pi capacitance. C pi capacitance, how can you represent 1 by j omega C pi, plus similarly the current in C mu, that is V pi divided by 1 plus j omega C mu. Therefore you can write it as V pi, it is a common, V pi as a common, therefore V pi of 1 by R pi plus j omega of C pi plus C mu. Okay, clear? Then where V pi is, that is where V pi you need to express, V pi you need to substitute R. So for this let us write the KCL equation at the output node. the KCL equation at the output node, that is at the collector. The KCL equation at the collector is given as V pi by V pi by the capacitance C mu. C mu is 1 by j omega C mu plus IC that equal to Gm V pi, that equal to Gm V pi. This is the KCL equation at the collector node, right? With this you can express the IC equal to V pi of Gm minus j omega C mu. Okay, V pi of Gm minus j omega C mu. Therefore, from this the V pi you can express as IC divided by Gm minus j omega C mu. Now substitute this equation V pi in the current equation, IB equation, Therefore, the IB yields like this. IB divided by IC. IB equal to IC of that much. Hence, the small signal current gain HFE you can define as IC divided by IB. IC is the output collector current, IB is the input base current. So IC divided by IB equal to, in the small signal case, the current gain is represented as HFE. Okay, so therefore HFE equal to Gm minus j omega C mu divided by 1 by R pi plus j omega of C pi plus C mu. Like that you can express the current gain, the short circuit current gain, that is HFE, like this. But with the typical values of C mu, and Gm, that is C mu is 0.05 picofarads and Gm is 50 milliamperes per volt. Usually the omega C mu is far greater than Gm. Therefore, HFE is approximately equal to Gm divided by 1 by R pi plus j omega of C pi plus C mu. Okay, and if you simplify it, you can get the equation is like Gm R pi divided by 1 plus j omega R pi of C pi plus C mu. If you observe here, the numerator part is Gm R pi, which is equal to beta. So HFE equal to beta divided by 1 plus j omega R pi of C pi plus C mu. Okay, that is the short circuit current gain. You can express. Okay, so with reference to this gain, the lower cutoff frequency or corner frequency, the corner frequency, or also called beta cutoff frequency. F beta is given by F beta equal to 1 by 2 pi R pi of C pi plus C mu. Okay, there you can observe that the denominator part omega is something like that. Okay, so there from that you can derive F beta equal to 1 divided by 2 pi R pi of C pi plus C mu. And this is the diagram representing the both plots for both magnitude and phases. So the maximum gain is beta, the maximum gain HFE equal to beta. So it is with the corner frequency F beta, it falls by increasing the frequency, right? And this is the phasor diagram. So if you observe here, the frequency is Ft when the gain is equal to unity. When the gain comes to unity, the frequency notation is referred as Ft okay. So with reference to this, you can also write the current gain equation like HFE equal to beta naught divided by 1 plus j into F by F beta. Therefore, the magnitude of HFE equal to B naught divided by square root of 1 plus F by F beta whole square. Okay. At unity gain, the notation for the frequency is Ft. Therefore, the magnitude of HFE equal to 1 that is at unity, the frequency is represented as ft. So by the simplification it comes like, by the simplification, okay, and since beta is far greater than 1 and ft is far greater than f beta, therefore it is approximately equal to, so 1 equal to beta naught f beta divided by ft. Okay, that is ft equal to beta naught into f beta, like that also you can express. So where ft is the unity gain frequency, unity gain frequency, unity gain frequency. Okay, so that is about the short circuit current gain and unity gain frequency. Okay, and it is expressed uh, like the unity gain bandwidth is, the unity gain bandwidth, the bandwidth means approximately, you know, the bandwidth is equal to higher corner frequency. Okay, the unity gain bandwidth is, that is ft, that equal to beta naught into, if you substitute that f beta value, it comes like this. Okay, in terms of gm, you can express ft as gm divided by 2 pi of c pi plus c mu. Okay, thank you. In the next class, you can see about the Miller effect and its applications.